Hey y'all, let's cover lesson 26, fractions and decimals. We're not done with fractions yet. Sorry, not until the final exam's done. And then we'll see you next semester with more fractions. To change a fraction to a decimal, well, we're going to divide. Divide the numerator by the denominator. A decimal that ends is called terminating. Okay. Change 15 divided by 48 to a decimal. So we're just going to divide it. 15 divided by 48 is 0.3125. 15 divided by 48 equals, or enter, is 0.3125. That's how you change a fraction to a decimal. Please pause the video and do the next one. And then if you want to try this one, please do so. If not, wait for me to do it. All right. 10 divided by 16. So just 10 divided by 16 equals, it's 0.625. All right. Change 3 and 7/20 to a decimal. All right, well, we could go around the world. We got a couple different ways we could do this. We could go around the world, 20 times 3 plus 7 over 20, and then divide it. Or you could do it another way. I want to show you this way first, and you decide which one you like better. I do not expect you to do both, but you figure out which one you like. We already know how to do this because we just came off of this from our exam. So 20 times 3 is 60. 60 plus 7 is 67 over 20. And then we would divide that. 67 divided by 20 is 3.35. And that's the answer. The other way to do this is just to go, okay, well, 3 is your whole number. So 3 point, and then whatever 7 divided by 20 is. 7 divided by 20 is 0.35. So 3 and yeah, it's 3.35. This could be thought of as 3 goes to here, and then 720 goes there. If that helps you think of it differently. So choose whichever version you liked of this, and then come do the next one. Okay, pause the video and attempt this yourself. All right, for those who are back, we're going to go around the world first. For those of you who chose to do that, 20 times 7 plus 11 over 20. 20 times 7 plus 11 is 151 divided by 20 is 7.55. So there's one way. The only thing you have to learn about this, because you learned about this in the last exam, is just once you get this answer, instead of making it a mixed number, you're just going to divide it with your calculator and get the answer. Okay, now I'm going to do this for the ones who choose to do it in this version. So 7 and 11/20. 7 is going to be the 7, and then we're going to have a decimal. And then 11/20 is just your 11 divided by 20 equals, and that's 0.55. And there you go. All right, a decimal that does not terminate will eventually repeat. The repeating section of a decimal is expressed with a line over it. So we're going to write 0.3 continuous using a repeat bar. So all I need is to write one of those, and that number is repeating for eternity. Okay, the next one is 0.456. I go until it starts repeating. Okay, now we're at it. 456, 456. So 456, that portion would need a repeat bar. Okay. We need to be careful with repeating decimals when using a calculator. For example, when changing 2/3 to a decimal using a calculator, the calculator will display a bunch of 6s, and then it ends in a 7. All right. So 0. And how many 6s do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9. So mine has up to 10 characters for there. 1, 2, 3, 4, 5, 6, 7, 8, 9, and there. The decimal appears to not repeat because it looks like that it stops at 7, but it doesn't. What happened is, however, the calculator has done what? The calculator has rounded it. The calculator rounded because this was a 6 and a 6. This number here, this place value was the rounding digit. The number over here was a 6 and it was its test digit, which means you have to add 1 to the 6, which made it a 7. And the rest of these disappear. Remember, after we rounded, you get rid of all the numbers to the right, past the decimal to the right. We need to be careful and recognize when this happens and what the repeating section actually is. So we're going to change 1/12 to a decimal. So I'm going to take 1 divided by 12, 1 divided by 12, and I get 0.083, 0.083, and the 3 is what continues. So if I'm going to represent using the line, the 0.083, the only piece that gets the line, the only number is that 3. Nothing else gets that line over it. The 3 is the only thing that's repeating. All right, now we're going to change 23 divided by 111 to a decimal. So I'm going to take 23 divided by 111 equals, I'm getting tired, 0.207207207. Make it into the other ones. All right, so for this one, that was pretty easy to see. It stops right here. So 0.207, and that whole thing is the repeating. All right. So those are our answers. Oh, nice. This is a short one. Okay, cool beans. Sweet. That last one felt brutal. We've just created some entities today. All right, so when we encounter expressions that contain both decimals and fractions, it is preferable to change all numbers to fractions, because fractions are always going to be exact as opposed to decimals, which a lot of the times are approximate. This is because not every fraction makes a terminating decimal. And in order to use repeating decimals, we would have to round them. And generally, we do not round until the very end. So the best thing to do is use it in fraction form as opposed to decimal. And I'm very sorry to tell you that. I wanted to see what 3/8 looks like. The only time, now see, in this case, I would be okay with you using decimals. And the only reason for that is because it's a terminating decimal. It's not a continuing decimal. So it would be negative 0.375 minus 1.25. I'd be cool with that. What is the other one they're giving us? The problem. 2/3. Now we have an issue. Okay, so now we have an issue because 2/3 does not come out pretty. We already saw that. It's 0.6 continuous, and so whatever number you give me is going to be approximate, not exact, and this is math, not science. So we like the exact numbers. So I'm going to do this one 2 ways, because I will accept this. Well, of course, in fractional form, but because I will accept this because this is the exact number, you need to understand that. So I'm going to do the exact number first with the decimal. So 3/8. Yeah, I'm going to stop after this. 375. And we're going to subtract 1.25. This I will accept. Negative 0.375 minus 1.25. Negative 1.625. I would accept that completely. But let's do this in fractional form. Negative 3/8 minus 1 point. Well, this is, we're going to change this to a fraction. Remember, we write the whole thing, 125 divided by 2, so 100. There's my fraction for it. So I'm going to write it vertically real quick. Minus 125 divided by 100. This is what we're going to do for the next one, which is why I'm doing it. So you have this. All right, common denominator here. It's not going to be 100. let's think here. So 100, the next one would be 200. Does 8 go into 200? It does. Woot woot. So 200 is our denominator. 100 times 2, so 125 times 2 is 250, and this is going to be a negative, and this is a negative. That means that this is going to be a negative. 8 times 25 is 200. 3 times 25 is 75. All right, now because the signs are the same, we're going to add them. So 75 plus 250 is 325. Already got the negative sign, so we've covered that. How do we want to answer this? We're answering it in fraction forms. Okay, well, we'd have to reduce this. So let me think here. All right. I wouldn't even do this. I would put this in decimal form. We're no longer doing the fractions necessarily. So 325 divided by 200 is what? Oh, perfect. 1.625. Negative 1.62. Well, I should have known that. 5. All right. The other one over here, let's go ahead and just do this in a fraction so we have it. Negative 2/3. And then this is going to be 35 over 100. All right. 3 does not go into 100. So the next one would be 200. Oh, I can reduce this. I can totally, let's reduce this first. Oh my gosh. So this will be negative 2/3. Make my life so much easier. 5 goes into this 7 times. 5 goes into this 20 times. So 7 over 20. Oh, so much nicer. Oh my gosh. Y'all. Why didn't you tell me? Common denominator between 3 and 20. Be 20, 40, it'd have to be 60. 60 is what they both would go into. I would look at the big one, see what it's going to work for. 20 times 3 is 60. 7 times 3 is 21. 3 times 20 is 60. Negative 2 times 20 is negative 40. The signs are different. We have to subtract them and keep the sign the largest, which is going to be a negative 60 denominator. And then 40 minus 21. 19. But there's the fractional form for that. I wonder what it looks like. This should be kind of weird decimal wise. Yeah, it's just absurd. All right, that is it for this lecture 26. I'm going to take a break and I will not get lecture 27 and 28 out until probably Monday night. I'll do my best.